uh, you know,
And is that for like pensions and things? That's what I was looking at is, there's so much money in the pensions for police department and all that.
yeah, yeah.
Hi, Robert. Hi, Anna.
Hello.
Hello.
Hi.
Hi. I love all the kitties
Yeah.
and the pup.
And
Yeah.
the puppy, yes.
Oh,
Gonna start.
excellent.
Live
Unmute.
stream is on.
Okay.
There's a break room in case breakout room if people need to have other consultations. Anyway, welcome to Dis and Dat, the Autonomous Collective.net 422. Well, I came across this idea about because I was looking into problems about or the concept of and what's interesting about how it sits in a bunch of different disciplines and kind of moves around a little bit for something called singularity. So seems less singular in that context. But so I hadn't thought about big history, but I came across big history, and so I'm going to do a little thing. It's an article by two guys who wrote about the 21st century singularity and global futures, a big history perspective. And it did remind me that there are a lot of little fanciful investigations about these matters. And so, given that I had all these things to think about, I asked Gemini, because I'm lazy, um, what Karl Marx would have thought of the concept of big history. And so this is what Gemini told me, um, which does demonstrate how sort of Gemini as a AI plugs in certain ideas and doesn't stray from them. It is quite statistical in that sense. Karl Marx's likely view of the concept of big history would be complex and likely contain both points of resonance and significant critique. Here's a breakdown of what he might think. Points of potential resonance. Materialist conception of history, big history at its core attempts to explain the universe and human history through a materialist lens, starting with the Big Bang and tracing the development of stars, planets, life, and finally, human societies. This aligns with Marx's historical materialism, which posits that material conditions, the means of production, and economic structures are the primary drivers of historical change. Marx would likely appreciate the attempt to ground historical understanding in material processes rather than idealist or theological explanations. Long-term evolutionary perspective. Marx's own historical framework, while primarily focused on human societies, envisioned a long-term trajectory of historical development through different modes of production. Big histories expansive timescale could be seen as a grander version of this evolutionary perspective, placing human history within a much larger cosmic and biological context. Interconnectedness. Big history emphasizes the interconnectedness of all things, from the formation of elements in stars to the development of complex ecosystems and human societies. While Marx focused on social and economic interconnectedness, he recognized the fundamental relationship between humanity and nature. He might find the broader interconnections presented by big history intriguing. Points of significant critique. Lack of emphasis on class struggle. A central tenet of Marxist thought is the concept of class struggle as the primary engine of historical change within human societies. Big history, with its vast scope, tends to downplay or generalize the specific dynamics of class relations and exploitation that Marx saw as fundamental. He would likely argue that big history glosses over the crucial power dynamics and social conflicts that shape human history. Potential for technological determinism. Marx was wary of purely technological explanations for historical change. While he acknowledged the importance of the forces of production, that is, technology and resources, he emphasized that the relations of production, social and economic organization, were equally, if not more, crucial. He might see big history's narrative as leaning toward a form of technological determinism where technological advancements are presented as the primary drivers without sufficient analysis of the social and economic contexts that shape their development and impact. Abstraction from specific social formations. Marx's historical materialism is deeply concerned with the specific characteristics of different modes of production, e.g., feudalism and capitalism, and the unique forms of exploitation and social relations they entail. Big history's broad strokes might be seen as abstracting away from these crucial specificities, failing to adequately analyze the qualitative differences between various human societies and their internal contradictions. Teleological implications, potential. While big history doesn't necessarily have a predetermined endpoint, some interpretations might suggest a linear progression toward increasing complexity. Marx, while believing in historical progress in a broad sense, did not subscribe to a teleological view of history with a preordained outcome. He saw history as shaped by human agency and struggle, not by an inherent cosmic plan. He would likely be critical of any implicit teleology in big history narratives. Ignoring the leap from the realm of necessity to the realm of freedom. For Marx, the ultimate goal of historical development was the overcoming of alienation and exploitation, leading to a communist society where humanity could consciously control its own destiny. You might see big history's focus on vast timescales and cosmic evolution as distracting from the urgent task of achieving social and economic liberation in the here and now. In conclusion, Marx would find big history's materialist approach and long-term perspective somewhat interesting and potentially useful as a broad backdrop. However, he would almost certainly critique its lack of focus on class struggle, its potential for technological determinism, its abstraction from specific social formations, and the dynamics of exploitation, and any teleological implications it might carry. For Marx, human history, even within a grand cosmic narrative, must ultimately be understood through the lens of social and economic relations and the ongoing struggle for a more just and equitable society. He would likely urge big history proponents to integrate a more critical and class-conscious analysis into their grand narrative. Now, that's what Gemini would think of all of this. You'll note that it does its usual thing by introducing certain key ideas and then summarizing at the end. I think it's a little broader than that. And of course, in the minutiae, one can argue, and this is not Gemini, in economics, Kondratiev waves, also called supercycles, great surges, and long waves, K waves, or the long economic cycle, are hypothesized cycle-like phenomena in the modern world economy. The phenomenon is closely connected with a technology life cycle. It is stated that the period of a wave, a Kondratiev wave, ranges from 40 to 60 years. The cycles consist of alternating intervals of high sectoral growth and intervals of relatively slow growth. Long wave theory is not accepted by most academic economists. Among economists who accept it, there is a lack of agreement about both the cause of the waves and the start and end years of particular waves. Among critics of the theory, the consensus is that it involves recognizing patterns that may not exist, some sort of delusion in that sense, apophenia. Now, speaking of which, I came across this little comparison of time for Deleuze and time for the Nicklandians. Nick Land wrote about such big things as well as Deleuze. And you can sort of see this, but this will get us off track here because it has that little kind of post-structural thing going on in there. But it is an interesting idea. Anyway, there's lots to talk about in terms of that issue. But back to big history. Big history seeks to understand the integrated history of the cosmos, Earth, life, and humanity using the best available empirical evidence and scholarly methods. And this is from the bighistory.org site. And so the past is something like 13.8 billion years ago. It kind of looks like this, or at least when you consider the ability of telescopes these days to measure out to the end, and you can see quantum fluctuations, inflation, afterglow light pattern of 375,000 years, a set of dark ages. The first stars is at 400 million, et cetera, et cetera. And then, of course, accelerated expansion. But the Big Bang expansion is 13.8 billion. You may have thought it was even more than that. And on the site, it gives us a kind of general description of this history. And this is what its timeline, what would look like from the quaternary to the beginning, the earliest Earth. And instead of the religious version of 5,000 or 6,000 years, it's more like many millions. So anyway, there is a section here that describes the origin of life, and the underlying question is, can big history help us now? And the whole point of big history is to address the potential singularity of the problematic events that are represented by climate change or climate crisis. So there's that set of descriptions, and there is a series in this one specific article on big history, a series of graphs which we'll get back to in a second. So there's a little overview by Andrei Korotayev and David Lepore on the singularity in big history, and it overviews their recent book. Many major transitions are currently underway in demography, energy use, environment, economic convergence, and global interdependence. With so much rapid change, the timescales for decisions are often limited to about 5 years in the future. Somewhat paradoxical, then, that this current rapid change is guiding us to look at very long timescales. This motivation arises because one explanation of the current rapid change is that it is a continuation of a very long-term trend throughout big history. Only now, when we observe the change trend within our lives, do we fully appreciate the consequences and implications. Our recent book, The 21st Century Singularity and Global Futures, A Big History Perspective, helps understand the basis for this view, along with the various deeper explanations as to why it's happening, as well as why we can understand it. But beyond just understanding, we attempt to articulate some of the potential issues and implications to help facilitate future scenario development and their considerations. The book first presents a definition of a singularity trend. This is then placed into the context of big history. The following chapters that analyze evidence and historical megatrends suggest potential models, review possible interpretations, develop future scenarios, and raise philosophical questions. Now, this is done with the realization and debate about the analysis limitations and uncertainty. Many major transitions are blah, 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 which so much rapid change, the timescales for decisions are often limited to about 5 years in the future, et cetera, et cetera. The motivation arises because, there's an explanation for the current rapid changes as a continuation of a very long term throughout big history. According to the definition of the they must have amazing conferences. The International Big History Association. Big History seeks to understand the integrated history of the cosmos, Earth, life, and humanity using the best empirical evidence and scholarly methods. There are many standard accounts of big history. Only now, when we observe the change trend within our lives, do we fully appreciate the consequences and implications. A big history perspective was written to help understand the basis for this view, along with various deeper explanations as to why it's happening, as well as why we can understand it. But beyond just understanding, we attempt to articulate some of the potential issues and implications to help facilitate future scenario development and the consideration. The rapid change leading to some essential singularity was articulated early by John von Neumann in the 1950s. The ever-accelerating progress of technology and changes in the mode of human life gives the appearance of approaching some essential singularity in the history of the race beyond which human affairs as we know them could not continue. Later, Carl Sagan popularized the cosmic calendar to demonstrate the relatively early slow rates of change with life evolution, but accelerating rates of change towards today. While the time scale of many events is somewhat known, some of the major questions in this history are not fully understood, namely the nature of the Big Bang, the dark substance of the universe, the origin of life, the meaning of consciousness, and the sustainability of technological civilization. It is important to explore these topics and trends, not just to further understand their origin, but also to put into context our possible future scenarios, to interpret trends, and to help guide decisions by identifying options and possible consequences. Often, civilizations at a smaller scale have failed to be sustainable because of their belief in the continuing expanding trends without regard to their marginal benefits. So, we approach this topic understanding the limitations of data, interpretation, and trend extrapolation. It is important to remember that the megatrend toward a singularity does not mean that the singularity will happen, but instead that there might be some limitations and changes in the trend. In this book, we have various perspectives, from those interpreting the continuing pattern as toward a technological singularity that is a bounded logistical pattern or no pattern at all. A big history context. To place the accelerating trend of complexity in the context of big history, we need to distinguish the two forms or arms of mega evolution so far in the universe. The first arm of mega evolution is the decelerating development of physical matter and energy into galaxies, stars, and planets from the initial Big Bang. The second one is the accelerating rate of complexity evolution in the form of life, humans, and civilizations, which is the main concern of our book. See figure one. Figure one is this figure, mega evolutionary processes in the big history perspective. So arm starting at the lower bottom left shows increasing complexity. And the other arm is the enabling system, the natural or technological environment, early universe, et cetera, ecosystems, stone tools, technology, microchips, nanotechnology. So as the size of the increasingly complex objects grow, the smaller the system or tool involved. So you see, something that gets more complex and something that gets smaller. The line showing the construction of larger atoms, nuclei, by supernovae is a critical step leading to planets which enable the second arm to develop and accelerate. So that's kind of what the two arms that they're talking about here. Let's see. This increasing complexity requires additional information to overcome the second law of thermodynamics, tendency towards thermal equilibrium, that is, death. Instead, it marches further from this natural equilibrium toward a stable disequilibrium maintained by a constant flow of energy under information control. This concept of complexity correlates with various definitions of complexity in mathematics, such as the minimum length of the text describing its structure. Both arms proceed from combining two existing structures to form a new emergent structure. This process is known as aromorphosis. Between these jumps of structure, there's a rather smooth evolutionary process. A complex system cannot arise from scratch. Such a system is always the result of combinations of systems of the previous level of evolution. Evolution is not engaged in strategic planning and preliminary calculation of its aromorphosis. It only works with the material that it already has at hand and can immediately use. Trends first. The data are collected and analyzed. Surprisingly, much data seems to fit a relatively simple model along with high-level explanations correlative. The idea that in the near future we should expect the singularity has become quite popular recently, primarily thanks to the activities of Google technical director in the field of machine training, Raymond Kurzweil, and his book, The Singularity is Near. It is shown that the mathematical analysis of the series of events, which starts with the emergence of our galaxy and ends with the decoding of the DNA code, is indeed ideally described by an extremely simple mathematical function with a singularity approximately in 2029. This is similar to the earlier independent analysis by the Russian physicist Alexander Panov. This function is also similar to the equation discovered in 1960 by Heinz von Förster concerning the dynamics of the world population. All this indicates the existence of global macroevolutionary patterns covering the period of a few billion years, which can be surprisingly accurate, described by extremely simple mathematical functions. However, there seems to be no reason to expect a continuation of this trend to be an unprecedented acceleration of technological development near the time of the trend's singularity. Instead, it is reasonable to interpret this point as an indication of an inflection point after which the pace of global evolution will begin to systematically slow down in the long term. The Other potential historical trends are discussed that include integrating long-range topics such as geology and biology, as well as the potential for the trends end with the complexity of developing artificial intelligence. If viewed as a complex adaptive system, there are expected to be patterns in related aspects such as energy flow and information. The impact of human perception is raised to question the reality of these trends. However, the trend seems to facilitate understanding of these long timescales. Next, we consider potential models at various levels of abstraction. While the simplest, most mathematical and abstract model is the modified exponential growth with collective learning leading to a hyperbolic form as presented in Figure 2, there are many other aspects to consider. These aspects include the analogies to physical and social systems, more detail in the dynamics, questions about stochastic effects, and patterns that may continue beyond the unique singularity or inflection time. So that's what this time before the singularity looks like. You can view that as your leisure. That is it describes or plots time versus macro development rate, the frequency of phase transitions per year, and so moves from information evolution to the emergence in terms of current time. So back to the thing. It's a Figure 2, scatter plot of the phase transition points from Panov's list with the fitted power law regression line, the double logarithmic scale, for the singularity date identified as 2027 CE with the least squares method. Debate continues whether the rate of change at the singularity will further accelerate, slow down, or demonstrate other behavior. I think I have the topic for my next protest sign to carry. Anyway, e.g., flattening, collapse. Very basic questions about this historical trend concern the causes such as mathematical conditions of growth and factors like energy, environment, and information. Further details include determination of indications of the singularity's behavior, for example, time, number, and type, and the pattern of substructure, for example, timing transition characteristics leading up to the singularity. Finally, possible extensions to the pattern are considered in cosmological history, near-term transition to sustainability, and construction of potential far future scenarios and implications. Future implications. Potential future implications, scenarios, and actions are developed and presented. Future implications include effects of more integrated cyber and human, i.e., cyborg systems, initiatives like the Global Brain Project, and applications of new fundamental technologies, especially to medicine. Scenarios often include the potential for the rate of change to slow down due to increasing complexities or aging due to demographic trends. Identified actions include educational awareness, greater international collaborative efforts, and applications of strategic foresight. Insightful implications of a slowdown after a singularity might be the relative speed at which other similar civilizations progress. This leads to another possible hint at the resolution of the Fermi paradox. And figure 3 shows some of the topics and modeling approaches from demography, economics, and science, all centered around technology. These include, from upper left clockwise, population growth, worldview changes, environmental interests, science discoveries, depletion of fossil fuels, and correlations of population growth and inequality. And that's diagram 3 here, which shows some of the different examples, including environmental action, fossil fuel use, population growth rate and inequality, human existence, and physics discoveries, etc., and triangulating essentially population, science, and economics stuff around technology. Needless to say, that's kind of where the current crisis may emerge. So, epistemology. The chapters of this book, of this part of the book, seek to answer such questions as: how can we know this trend? How is this related to our evolution of worldviews? How much is the matter of perception relevant? Can we divide the hyperbolic acceleration into major phases and logistic nested progress? Conclusion. Every part of the book presents a brief summary of the findings and integrates them into a current perspective of approaches, issues, research gaps, implications, and controversies. The approaches include the way each of the trends were constructed and analyzed, along with the critique and attempts at resolution as presented in other chapters. Research gaps were identified in many chapters, including collection and validation of data, for example, energy flow throughout history. Implications are identified throughout the book, including the way history is viewed, the way potential future scenarios are constructed and analyzed, and the potential for SETI, search for extraterrestrial, life. In general, it is shown that the study of the 21st century singularity allows detecting a number of sufficiently rigorous global macroevolutionary regularities describing the evolution of complexity on our planet over a few billions of years, which can be surprisingly accurately described by extremely simple mathematical functions. Well, we can see there could be issues with all of these matters. So I've introduced this idea. I won't read through the massive description of in my in a David Attenborough way, but I'll skip to the point of, does big history provide a narrative that can help nurture the development of the empathy and cooperation that are part of our social nature? Can humans form a more perfect human community as we continue to create a more complex society than has existed before, or will our current levels of social complexity face inexorable demise? The long-term future Whatever the answers to these questions, any species still surviving on Earth a few billion years from now would be well advised to hop a spaceship to another solar system. Those still on Earth will face a much hotter sun. About 5 billion years from now, the sun will run out of hydrogen fuel in its core, and will grow into a red giant, evaporating the oceans and possibly engulfing the Earth. The sun will eventually eject its outer layers, leaving behind its core, a white dwarf that will cool and fade over trillions of years. Meanwhile, other galaxies may keep racing away from our own local group of galaxies, perhaps leaving us with a sky devoid of the images of distant galaxies that have contributed so much to our understanding of the universe and the cosmic context of the Earth. Have other universes already existed? Will there be more universes after ours has ended? Are there an infinite number of universes, perhaps with some even sharing our space? Ooh. The trend of life's accelerating increase in complexity throughout its history on Earth suggests that a unique time, that is, a unique or singular event like singularity, might be realized soon. At this unique time, the growth trend might display unusual behavior. Debate continues whether the rate of change at the singularity will further accelerate, slow down, or demonstrate other behavior, e.g., flattening or collapse. Very basic questions about this historical trend concern the causes, such as mathematical conditions of growth and factors like energy, environment, and information. Further details include determination of indications of the singularity's behavior, for example, time, number, and type, and the pattern of substructure, e.g., timing, transition characteristics leading up to the singularity. Finally, possible extensions to the pattern are considered in cosmological history, near-term transition to sustainability, and construction of potential far future scenarios and implications. And to give you the basic definition, singularity can mean a separate unit, a peculiarity, or a point of infinite density in space-time. So in system theory, singularity in dynamical and social systems, a context in which a small change can cause a large effect. Gravitational singularity in general relativity, a point in which gravity is so intense that space-time itself becomes ill-defined. Technological singularity, a hypothetical point in time where technological growth becomes uncontrollable and irreversible, CAI. So, anyway, I knew this was going to be a little short today, but I just thought I would introduce this idea. I like the idea of big history, although I think Hegel would not, what would it be? Uh, it would be große Geschichte or something, right? um, anyway, so, I leave it to you to sort of think about how some people who have a mathematical bent try to put together singularity in big history. And I am interested in the idea that people do have something of an interest in thinking about this big picture thing, which has obviously changed with the advent of better satellite telescopes, etc. So I sort of leave it there. Let's see if there are any queries in the chat. Submission to AI is voluntary. They piss singularity thinkers are very interesting but deeply wrong in thinking inevitable. They piss me off as much as the Catholic Church. Yes. The Anthropocene or mass extinction, initiating other global changes not seen in millions of years. Indeed. On the cosmological scale of time, human existence would seem to be incredibly insignificant. Yes, but responded insignificant on a time scale, but significant in effect. And yes, this was my little contribution to Earth Day, and to think a little bit larger on larger scales. And maybe people will look up big history and see, there's an interesting idea. Whether a singularity fits into big history or how it fits into big history is sort of an interesting question. And, it is a pretty cosmic, as they say, in terms of trying to calculate what the hell is happening or what has happened and our own significance or insignificance on the planet. So happy Earth Day. And I will, unless there are any questions, I will thank you for your attention and get us off the live stream so we can get on to other matters. The Red Hour is tonight, and with an interesting story, I think, I hope. And if Bruce is around, he can describe that. But let me thank you for your attention and stop share.